6.2 Stars and the Universe Memo. 1. Explain the process of nuclear fusion within stars, while hydrogen nuclei will fuse together to form helium. B. In which regions of the electromagnetic spectrum do stars emit most of their energy, while they emit them in the infrared, visible light and ultraviolet sections of the spectrum? Number 2. Circle the approximate number of stars in a typical galaxy. Well, there are literally billions of stars in a typical galaxy. Define the light year. Well, it's the distance light travels in the period of a year. Circle the distance of 1 light year in meters. Well, it's 9.5 times 10 to the 15 meters, something you are required to know. Our local galaxy is called the Milky Way. And what's the approximate diameter of our local galaxy in light years? It's 100,000 light years. Order the events of the life cycle of a star from 1 to 7. Well, number 1 is an interstellar cloud collapses under the influence of gravity, becoming hotter and forming a protostar. Number 2, the protostar stabilizes when the gravitational force is balanced with the outward pressure caused by nuclear fusion. Number 3, eventually the star will run out of hydrogen. The star will then, number 4, expand as a red dwarf, and now that the hydrogen has run out. Finally, the red giant will actually explode as a supernova. A planetary nebula will form with a white dwarf in the center, and then maybe possibly number 7, the nebula may form a new star and planets. Number 4, light from distant galaxies is said to be redshifted. What does that mean, to be redshifted? Well, as the universe expands, the wavelength of the light is stretched, shifting the frequency of the light towards the red part of the spectrum. How does the redshift of galaxies support the Big Bang Theory? Well, the majority of galaxies that we observe have light that is shifted towards the red part of the spectrum. The further away the galaxies, the greater the shift, as those galaxies are receding fastest. C. Radio astronomers have observed something called the cosmic microwave background radiation with radio telescopes. What is the CMBR and how does it provide further evidence for the Big Bang? Well, the CMBR was radiation produced during the Big Bang that has been shifted into the microwave section of the electromagnetic spectrum as the universe has expanded. D. Define the Hubble constant H0. Well, H0 is the ratio of the speed at which a galaxy is receding to the distance from the Earth. State the value of the Hubble constant. Well, it's 2.2 times 10 to the minus 18 per second. Next, we've got this galaxy NGC 7768 is 220 megaparsecs, 3.7 times 10 to the 24 meters away from our galaxy. Using the Hubble constant, predict the speed with which it would be moving away from our galaxy. Well, we're going to use our equation. D equals H0 D times H0 equals V. So 3.7 times 10 to the 24 times 2.2 times 10 to the minus 18. Well, we get 8,140,000 meters per second. Now, actually, that's not realistic because that would be traveling faster than the light. But it was good practice for you to have a go at using the equation. G, use the Hubble constant to estimate the age of the universe. Well, 1 over H0 is the approximate age of the universe. So 4.5 times 10 to the 17 seconds, which is roughly 14 billion years.